Okay, so before we dive into our next example, I'm going to give you a little, it's kind of like key concepts, but a little different. So on your paper, you should see this statement. So all probabilities range from blank to blank. So all probabilities, no matter what they are, will only range from 0 to 1, meaning they won't be any less than 0. They can be 0, okay, and we'll learn what that means in a sec, but they can only range from 0, so not past, not negative, to 1, and again, not past 1, so only 0 to 1. Okay, so underneath it you should see this number line. I know it's a little hard to read on mine, but less likely, more likely, those are on your paper. So, so again, we just learned all probabilities range from 0 to 1. So we've got 0 on our number line, so it's going to range from 0 all the way to 1 on this far side. Okay, so you can fill in that box with a 1. Now you should have another box up here, halfway between 0 and 1 is, you said 1/2 or 0.5, you're right, we're going to write 0.5 on here. All right, so fill in that box with 0.5. So now we've created our number line to illustrate probability. Now we're going to talk about what it means, okay? So if you see on yours it's purple, on mine it's red, you have more likely with an arrow pointing towards 1 and less likely with an arrow pointing towards 0. What this means is that if something is 0.5 or greater, so between 0.5 and 1, or equal to those two, it is more likely to happen. So the probability of it happening is greater. And in turn, from 0.5 to 0, between those two, it is less likely to happen. Now, if a probability is 0, this is called an impossible event, meaning it's never going to happen. So you can fill in that line with impossible. Okay, so meaning not going to happen. If you look at a probability and it equals 0, it's saying it's never going to happen. Okay, so it's impossible. And then if a probability equals 1, this means it's definitely going to happen, and it's called a certain event. So you can fill in that line with certain. Meaning if you're finding the probability of something and it ends up equaling 1, it's going to happen for sure, without a doubt. Okay, so basically, this number line illustrates that statement just so you have a better understanding of what it means, okay? Then at the bottom of your page, you should see a vocab word. So we talked about outcomes and events and then probabilities of events at the beginning, in example 1, before example 1. Now we're going to talk about complements, okay? So the complement of an event, okay, is the opposite. So saying if, let's talk about the odds of getting an odd number. So the probability of getting an odd number that we used in example 1. So the probability was 1 in 2, okay, or 3 in 6. Its complement would be 1 over 2 or 3 over 6. It creates that whole. Another example would be the probability of getting a 2 on a number cube, okay? So the probability of getting a 2 on a number cube we said was 1 in 6. So the complement of that would be 5 in 6. So if you add 1/6 and 5/6 together, you're going to get 1 whole. So the complement completes the probability, the probability, okay? So when you put the two together, it's going to equal 1. All right? So let's talk about example 2. Let me give me a second to move my board. Okay, so example 2, we're going to apply it to the real world. I know these aren't your favorite, guys, but we're going to try it. So on your paper, you should see this. In the U.S., the probability that a child is a twin is 2 in 90. So it's saying for every 90 people, there's a probability that 2 of those 90 will be twins, okay? We're going to find the probability that of the people that are not twins. So again, we're finding the complement. So this would be the complement of our probability here. So our first step, you'll see it on your paper, write an equation, okay? So the way we write this equation, when you have complements, okay, you usually add them together, so we're going to add them. Okay, so we know the probability of twins is 2 in 90. So we're making that a fraction. Okay, I know it's hard to see. 2 in 90. Trying to hide that glare, guys. All right, and then we're going to add its complement. So the probability of not being a twin. I'm going to save some space, guys, because I'm running out of space. And again, we talked about when we add these two things together, it should always equal. If you said 1, you're right, okay? So is equal to 1. So now we have an equation. So think of this probability like a variable, okay? You guys have used balanced equations before. You know how to do it. So instead of just being one letter, it's a little statement, but treat this like a variable, okay? So first things first, we have to, excuse me, balance the equation, okay? So, oh, I'm so sorry, guys. I skipped a step. So instead of putting 290, we're writing the complement, probability of a twin. Everybody makes mistakes, sorry guys. Hopefully you're doing this in pencil, or you got some whiteout, okay? So let's rewind for a second. So again, we're talking about complements. It doesn't change the concept at all, but just so you can illustrate it. So the probability of being a twin plus the probability of not being a twin will equal 1 because they are complements of each other. They're opposites, okay? So now we're going to substitute. Okay, so step 2, now we're substituting the one that we know, which is the probability of being a twin, which we already wrote it, 2 over 90, okay? So I'm going to rewrite this really quick. Sorry for my funky P. Okay, so now we substituted it and we've got our equation. So now we're going to balance it. Now the way we balance it, I've given you that step. You're going to subtract 2 over 90 from each side. So think about, why are we subtracting 290? Why aren't we subtracting the probability or the 1? Think about what you know about balancing equations. Okay? So again, if you said we're subtracting 290 because we want to get our variable by itself, you're right. So if we subtract 290, I'm going to use, let's use pink. We're subtracting 290 from both sides, right? I'm going to squeeze this in here. I'm sorry, not 290, 2 over 90. All right, we subtract it from both sides. This cancels out, right? So we're left with the probability of not being a twin, or not a twin. Okay, and that's going to be equal to 1 minus 2 over 90. Now remember, we got a little confused that one time when we were subtracting to balance the equation. Okay, so remember, make sure that whatever's being subtracted comes after the number that was already here. Okay, so make sure it comes after. All right, so we have 1 minus 290. If it was the other way around, we get it wrong. Okay, so we subtracted 290 from each side and we got the probability of not being a twin or not having a twin is equal to 1 minus 2 over 90. So now we're going to simplify it. So the easiest way to do this, we know for one whole, the numerator and the denominator have to be the same, right? So we've got a denominator of 90 here, so we're just going to use the denominator 90. So we're going to create this, and this is going to become, I'm just going to cross this out, 1 becomes 90 over 90, because we know 90 divided by 90 is 1. So now we have 90 minus 2. What's 90 minus 2? Hopefully you said it. It is 88, so it's 88. So the probability of not being a twin is 88, I know that's a large number, over 90. Now, I will tell you this, it can be reduced, okay? So, not such a crazy number, okay? Use your rules of divisibility. Hopefully you have your little flip book. Okay, these are both even numbers, so we are going to divide it by 2. So 88 divided by 2, you get, I'll give you a second to do it, or if you want, you can pause the video. You may be using your calculators, okay? So 88 divided by 2, you should get 44. And 90 divided by 2, you should get 45. And that's it. We can't reduce that anymore. I'll just tell you guys that here. So 44 over 45. So we need to put this in a statement. The probability that a child is not a twin is 44 out of 45. So 44 over 45. Okay? Simple as that. On what I want you guys to do, I'm not going to write it on the board, but I want you to look in your pocket for the practice problems. They say, when you roll a number cube, what is the probability of not getting a 2? We kind of talked about that. And B, what is the complement of an impossible event? So this is just going to be a statement, okay? So it's just saying, what is the complement of an impossible event? So think about that number line that we use. So I'm going to give you a second. Again, pause the video if you need more time, okay? I'm going to give you about, let's say 10 seconds. Again, if 10 seconds isn't enough, pause the video. All right, that might not have been exactly 10 seconds, but you can pause the video if you'd like at this point. So For when you roll a number cube, what is the probability of not getting a 2? So again, we found the probability that getting a 2 would be 1 out of 6. So the probability of not getting it would be the complement, which should be 5 over 6. So you should have gotten 5 over 6 for A. Then for B, what is the complement of an impossible event? So remember, look at that number line. The complement is the opposite. So if this is an impossible event, the complement of it should be a certain event. So for B, you should have answered a certain event. So again, they're at opposite ends of each other. Okay, complements are when they complement each other, it's the opposites. Okay, so your answer should have been a certain event. All right, so be on the lookout for the next video for example 3. Only going on to it when you're ready.